Yes, welcome to Easy Gates, Gate 22 Electronics and Communication Paper Solutions once again. So let us get into the next problem. Next one from electrical circuits. Very easy problem. Belong to AC circuits analysis. A multiple choice question, MCQ. So what is given? A simple series circuit is given having a 1 ohm resistor, excitation given, you can take it as V in of t. That is sine of t volts. That means usually it should be in the form of A sine omega t, A, or you can also take it as Vp sine omega t. Okay, so it is an amplitude. So given Vp is equal to 1 volt and omega is equal to 1 radian per second indirectly. Yes, we should get this data from the given AC excitation. So it's a sinusoidal steady state analysis. In the given circuit, the unknown element is at this. So the input excitation is given and the resultant current drawn by the circuit from the source is given as I of t. So this is the instantaneous current waveform, okay, in the given circuit. And it gives some information. What the information it is giving? The input signal is beginning with, even you can write the input signal as Vp sine omega t plus phi. Okay, that's a very standard form of a sinusoidal excitation. So where the phi is equal to 0 degree, that means your input waveform begins with 0 degree, whereas the given current waveform actually begins at pi by 4 radians. That is nothing but 45 degree. Pi you can take it as 180. So it's 180 by 4. So it is 45 degree. That means your current is lagging your excitation by an angle. Okay, you can take, okay, that is 45 degree. Okay, current lags your voltage by an angle 45 degree. That means you can say the input as 1 volt in the form of Vp. So this is 1 at an angle 0. I'm not taking RMS for this magnitude, but the rule of thumb by default in AC circuit analysis, you have to take only the RMS for the magnitude. Let me take it as a peak value. So it's 1 angle 0 and we are getting the current. So current amplitude is given 1 by root 2. Let me take the current I as 1 by root 2 at an angle minus 45 degree. That's what the current is. Remember, there's a peak current, there's a peak voltage. That's how I refer. So the peak current is given in the instantaneous waveform of the current. So, and also given it is lagging by an angle. That means the waveform begins by 45 degree, whereas the input waveform begins by 0 degree. So therefore, there is a phase lag of 45 degree between the current and voltage. That means we technically conclude the current lags behind the voltage by an angle 45 degree. So what circuit will make the current lag? So current lags means then straight away we can say it's an inductive circuit. It's a RL circuit, so current lags. Okay, what is the problem? In the given circuit, the unknown element is at this. So now we know the circuit is a lagging circuit. That means it's a RL circuit. Definitely only in RL the current will lag. So what does that unknown element means? So it should be an inductor. And what value? That's a question. So I didn't remember exactly the two more options. Okay, maybe they are in terms of inductor and capacitor only, maybe with the different values. But I remember this is 1 Henry and this is 1 Farad. Easy values to remember. So this is what I remember with respect to the problem. The problem is this: in the given circuit, the unknown element is at this given excitation, given the current response. So from this you have to play. So there are two ways of play. So one is the phase angle way. So what is the information given? The phase angle. Current phase angle lags by current is lagging by an angle 45 degree. That is one information. But amplitude of current you can take another information. So the input voltage amplitude is 1, but the current amplitude is 1 by root 2. We can also play by magnitude. So there is a way by magnitude. There is a way by phase angle. Which one is easy means the phase angle way is a little easier. Even magnitude way also easy. Let us see, okay, how to play with the phase angle way. Okay. So what is given is the current. Current is 1 by root 2 at an angle what? Minus 45 degree. Okay. That's current. What is fundamentally the current? The current is equal to the V in divided by the total impedance offered by the circuit. Okay. Total impedance offered by the circuit. That is nothing but your V in excitation is well known, divided by it is going to be R plus, okay, R plus Z. Okay, R plus Z, let me take, that's going to be imaginary. So you can take J modulus of Z also. Okay, so this Z is going to be imaginary. Okay, let me come to that point. Angle of I is known, and this is the angle of your I means. Then who is going to make the angle of I? Okay, the total impedance is going to make the angle of I. So the numerator angle will be angle V in, and denominator angle will be the angle of the total impedance. That means this is equal to minus 45 degree. Means who will contribute the angle? Angle of V in is 0, and therefore it is going to be angle of V in minus angle of Z total. That should be equal to what? Minus 45 degree. So angle of V in is 0 degree means, so 0 minus angle of Z total should be equal to minus 45 degree, means angle of Z total should be equal to what? 45 degree. That means the total impedance angle of the circuit should be equal to 45 degree, means, so what is the total impedance? So total impedance is R plus, let me take, already I said it's going to be a R and L because the current is lagging. So let me take straight away. Already I concluded it is going to be an inductor. The unknown element is going to be a inductor. So let me take Z as J omega L. Okay, so the inductor contribution is J omega L. That's impedance offered by the inductor. Okay. Yes. Then angle of Z total we know. What is the angle of Z total? That should be equal to 45 degree. That's a simplest way for this problem. Yes. Now, what is that? Tan inverse of omega L by R should be equal to 45 degree. Very simple. And R is given. So tan inverse of omega L by R, okay, should be equal to 45. Means what is omega L by R? What is omega L by R? And you know very well, as per the identity, tan inverse of 1 only equal to what? 45 degree. Therefore, you can also write, if you want, omega L by R should be equal to tan 45. So tan 45 is equal to 1. So omega L should be equal to R. That should be equal to what? Given 1 ohm. And omega is given already what? 1 radian per second. Therefore, L is equal to R divided by omega. So it's going to be 1 Henry. So that's your answer. This is by phase angle way. Okay. By playing for the phase angle of your total impedance. Okay. You can also go by another way. That is the magnitude way. What is the magnitude way? So you know your current. What is the current? Current is going to be V in divided by what? Z total. Okay, right? So from this, let me go for Z total. Z total is equal to what? V in divided by I. So let me go for the modulus of the Z total. What is modulus of Z total? We know the modulus of Vn. What is that? You can take RMS or amplitude, no problem. So what is the V in amplitude? It is 1 volt. What is the current amplitude? It's 1 by root 2 amps. So the resultant, what is that? Root 2 ohms. That should be the modulus of the total impedance. This is the magnitude way. It's up to you in the examination, but both are equally time consuming, either the phase angle route or this one. So the phase angle route is very intuitive. You will straight away imagine the contribution by the inductor is should be J1. Once you know it is J1, then only it is possible to get 1 plus J1 only can produce what? That required 45 degree angle. So straight away you can complete the problem by phase angle perception. But still, this is also an easier route. So let us go ahead with this also. So root 2 ohm, total impedance must be equal to root 2 ohm. And already again we have freezed, it is an inductor. Therefore, it is going to be R plus J omega L. Okay, this magnitude should be equal to what? Root 2 ohms. Then what is this? Square both sides. Then it's going to be R square plus omega L, root of this. Okay, root of R square plus omega L square should be equal to root 2 by magnitude way, and square both the sides. Then R square plus omega L, the whole square should be equal to what? 2. Then R square is, it's 1 square. So omega L square is going to be what? 1. And since omega is 1, so L is equal to, anyway, omega L is equal to 1. Plus or minus 1, but it is not going to be negative. It is plus only. So omega L is equal to 1. Therefore, once again, we can conclude that L, since omega equal to 1 radian per second, we can conclude L is equal to 1 Henry. Very simple problem. Okay. So in both the routes, it is taking, okay, same time almost. Okay. So, but the phase angle, intuitively, if you connect, it is very instant. I think it's a 2 marks problem, an MCQ problem. I didn't remember exactly the 2 more options. Okay. So therefore, the best possible answer for this problem, the best choices, option. Okay, an inductor of 1 Henry is enough to produce such a current waveform when excited by such a AC excitation. That's your word, sinusoidal steady state AC response analysis. Okay. So thanks for watching. We'll update you with one more problem soon. Okay, right? So subscribe our channel and also share to your friends. Okay. Wish you all the best and hope you get a better score in GATE 2022.